Hello, Mark. I heard the sound of a dripping water and I decided to check the tank out of curiosity. But to my surprise, I saw some water traces on the floor.
Victor, did you check the tank level? I mean the tank level on the HMI screen. Because the motor that is driving the pump should stop spinning. The inlet valve should also closes. And I hope you remember that. This are all part of a closed control loop system.
Yes, I did. On the HMI the tank level is not up to 80%. The inlet valves are open and the motor is active.
Okay. As long as the level is not up to 100%, the motor and the valves will be active. Are you sure you saw water drip or you're hallucinating?
Yes, boss.
All right. Let me put my laptop to sleep mode.
Is that water? Oh shit, this is serious. The whole floor is filled with water. Victor, please cut off the power going to the motor.
Now, this things do happens. Over time industrial instruments loses it measuring prowess after some time. Before we go a bit little further, if you want to learn industrial instrumentation, you can check my playlist on instrumentation. The working principle of pressure, temperature, level and flow meters was discussed extensively. Industrial instruments are made of electronic components. After some time this instrument will lose its measuring prowess. That is the signal to matter sensing ratio. For examples, for fluid level, it will be the amount of gallon to current signal ratio. Likewise for pressure transmitter, it will be the ratio of the pressure to current signal. And also temperature transmitter too. This error in ratio measurement can be due to temperature change, pressure, physical damage to the sensing diaphragm and changes in the ambient conditions. Sudden changes made to the vessels can also affect the instrument's readings. To fully understand this effects, let's look at a typical real-life examples. A clothing line that was fully tensioned during commissioning. We will notice after some time. That is when the line has been exposed to sunlight and cloth threading. We will notice that the rope tends to expand over time. And the whole essence of the rope will be defeated. Because the hung cloth will begins to touch the floor, which is what we don't want. And as such, in order to correct this natural occurring effect, the excess rope will need to be trimmed off. As we can see, the sagging rope is now tensioned. After trimming, the rope has returned back to its firm state and the cloth is no longer touching the ground. Now, the transmitters needs to undergoes trimming activities which is known as calibrations. So what is instrument calibrations? Instruments calibration is the process of adjusting the instrument's output in a way that it will represent what is obtainable in reality. Which is when the tank is empty. The output signal coming from the instruments should be 4 milliamps. And when the tank is at maximum, the output signals coming from the instrument should be at 20 milliamps. Now let's retrieve the level transmitter. It is important that the level of the tanks is less than 20%. And the pressure within the tanks is 0. Better still, the venting valve should be open. This is done in order to vent out the dangerous pressure within the tank, and to prevent injuries and damage to equipments. Now that there are no fluid pressure within, we will remove the sensor and inspect the tip from all indications. The sensing tip is free from mechanical damage. Now let's look at the current state of the capacitive level transmitter, which is in terms of the generated current signals at various fluid levels. With this, we will be able to understand the reason why the pump is not cutting off. We will connect a 24 volts power source to our level instrument, and a suitable ammeter will be used to measure the output signals of the transmitter. In this case, we are using a digital multimeter. We will empty our tank and have a look at our multimeter. The current gotten is 2.71 milliamps. This values is unacceptable. We will fill the tank to 50% of its capacities. We will look at our multimeter again. The current gotten is 7.5 milliamps. These values are not acceptable, because when we compare the value gotten with the transmitter data sheets, we can see that it is far off from what is expected. The graph shown a lot of hysteresis, and as such the deviation between the two graph is more than 0.2%. 0.2 deviation is the accepted tolerance value in some states, and it is the reason why the tanks overfills in the first place. Hence, there is need for recalibrating this instruments. We will empty the tank, and we will manually vary the span in such a way that the output current signals coming from the transmitter will be 4 mA for an empty tank. When the tank is empty, we will trim off the sensor by varying the span until the current is at 4 mA. After which we zero the instruments. Likewise, the tank will be filled to its maximum. A little glance on the sight glass is needed. Now that it has been confirmed physically, we will now need to increase the span from 7.5 mA up until it has finished leveling up at 20 mA. It is very important that the tank is at its maximum level before presetting the span of the transmitter, because this is going to be the measuring range of the transmitter. That is the typical 1 to 100 range of the tanks, or the 4 to 20 mA range of the transmitter. Now that the span has been preset, we will fill our tank and observe. At 0%, the HMI reading is also 0. Likewise, the current signals is 4 mA. At 35%, the HMI readings is also 35%, and the current signals is 7 mA. At 75%, the HMI is 75%, and the current signals is 15.1 mA. At 100%, which is the maximum level of the tank, the HMI is 100%, and the current signal is 20 mA. As we can see, when we compared the two graphs, we can see that the value gotten matches the transmitter value. and the hysteresis value is less than 0.2%. Now what we just did is called transmitter trimming. Because over time, instrumentation device loses its sensing accuracy, and it's very important to always calibrate them. Because this ensures product quality, because the right amount of fluid is used during mixing and blending activities. It also used to save cost, because the transmitter ensures that the right quantity of fluid is stored in a particular vessel. Finally, it is also an important device in a closed control loop system, because the starting of pumps and opening of valves may sometimes depends on the level of fluids within a vessels. Now let's do a quick recap. We started off looking at a typical day-to-day activities in a plant setup, and how this little device can result to an unwanted situation. From there, we look at the safety practices that must be followed when removing process instruments. We ended off looking at how capacitive level transmitter can be calibrated. In the coming series, we will be looking at how differential pressure transmitter can be calibrated. Hope you have learned something new today. See you in the next series.